air masses. In this lesson, we're going to talk about the major types of air masses. We will talk about the types of fronts, and then also we will look at the differences between cyclones and anticyclones. An air mass is a body of air that has a similar temperature, humidity, and air pressure. Remember, humidity is moisture content, the amount of moisture that's found inside of that body of air. The four major types of air masses that affect the continental United States are maritime tropical, continental tropical, continental polar, and maritime polar. Warm and cold air masses. Characteristics of air masses depend on their source regions, so the location in which they formed. If an air mass formed over top of an area that is cold, it is going to be cold. If it formed in a warm tropical area, it's going to be warm. Also remember that temperature affects air pressure. Cold, dense air has a higher pressure, while warm, less dense air has a lower pressure. So tropical or warm air masses form in the tropics and they have a low air pressure. And polar or cold air masses that form in the polar regions have a high air pressure. Think of it this way. If I have an air mass that is cold and it is sitting on top of me, cold air likes to sink. Cold air that is sinking down on top of you is going to increase atmospheric pressure. Warm air, if you have warm air on top of you, that warm air likes to rise. So that warm air is moving away from you. It is going to create lower pressure in the atmosphere as warm air moves away from you. Wet and dry air masses. Whether an air mass is humid or dry depends again on its source location as to whether it formed over top of land or if it formed over top of water. A maritime air mass is one that formed over top of water. Specifically, most maritime air masses form over top of the oceans. As water evaporates from the oceans, it is absorbed by the air that is above it, creating an area or a mass of air that is very humid. Continental air masses form over top of land, and those continental air masses that form over top of land have less exposure to water vapor, and so they do not have a very large amount of moisture inside of them. So continental air masses are drier than maritime air masses. So looking at this picture, we need to identify the type of air mass that comes from each of these sections inside of the picture. So if we have a wet air mass, it is going to have what source location? A maritime source location. If it is warm, where is it going to have formed? In a tropical location. So we know that as being a maritime tropical air mass. If we have a dry air mass, where did it form? Mr. Lovegrove? Continental. And it's warm. What does that tell us about its characteristic? Continental tropical. Very good. Alright, if it is a wet, cold air mass, it is what, Mr. Iyer? It is a maritime polar air mass. Very good. If it is a dry, cool air mass, it is a continental polar air mass. Alright, on the back of your sheet, there's a picture that looks like this. There are 6 source locations to air masses in the United States, specifically the continental United States. There are only 4 types of air masses, so obviously we're going to use one type of air mass more than once. So if we look at the first air mass, formed somewhere up around the Gulf of Alaska, or I suppose even parts of the Arctic Ocean. This air mass is formed in a northern region. What do we know about the temperature? It's cold, so therefore it is a polar air mass. But it formed over top of the ocean, so what do we know about it then? It is maritime, so it is a maritime polar air mass. What about over top of central Canada? The air mass formed over top of land, therefore it is continental. What do we know about its moisture content? What do we know about its moisture content? Not very much moisture. Okay? What do we know about its temperature? It is going to be cold because it formed in a polar region, so it's going to be continental polar. Very rarely do air masses that come that develop over the northern Atlantic hit the United States, but on very rare occasions they can. They kind of swoop back down from the south or to the south and kind of make their way a little bit westerly and kind of hit the northern New England areas. These air masses form in the northern Atlantic Ocean, so they are what? They are going to be cold, and they formed over top of an ocean. Okay? A maritime polar air mass is correct. Alright, the next one. We get it somewhere around the equator, around the tropics. So the air mass is going to be what? It's going to be tropical, and it formed over top of the ocean, so it's going to be maritime. So it's going to be a maritime tropical air mass. Air masses that form over top of the central part of Mexico and the United States Southwest. These air masses typically only form during the summer months. They formed over top of land, so they are going to be what? Continental. We know that they're going to be dry. And they formed in a tropical region, so they're going to be tropical. Continental, tropical. Very good. Alright, and the last air mass comes from the central part of the Pacific Ocean, so near the tropical regions. So it is going to be a warm air mass. It is also going to be an air mass that formed over top of an ocean, so it is maritime. So it is going to be a maritime tropical air mass. How air moves. Air masses move into new locations. As they move into new locations, they interact with the air masses that were previously in that location. This causes changes in weather. Sometimes those changes in weather can be drastic. There are two major things that affect the movement of air masses in the continental United States. They are the prevailing winds and the jet stream. The prevailing winds where we live are the westerlies. They are created due to the uneven heating of our planet and Coriolis. So the winds in the United States, the prevailing winds in the United States, move from the west to the east, moving air masses with them from west to the east. The jet stream is another thing that moves air. The jet stream is a band of very high-speed wind, about 10 kilometers off of our surface. The jet stream moves from west to east. However, the jet stream does some zigzags back and forth north to south. The jet stream is partially due to the extremely cold winter that we had this last winter. The jet stream moved way north, and it caught some really cold polar air from the polar vortex. It pulled that cold polar air back down to the United States, the continental United States, where those cold blobs of air ended up sitting over top of the central part of our country for long periods of time. The boundary where two air masses come in contact with one another is called a front. And the fronts are areas where storms and changeable weather often develops. So looking at this picture, we have 4 types of frontal boundaries that occur. These are areas where air masses come in contact with one another. The first one in the upper left-hand corner shows an area of cooler air pushing into an area of warmer air. And remember, cool air is more dense, so it kind of works a little bit like a bully, where it kind of just pushes its way in and moves things out of its way. That is a what type of front? Cold front. A cold front forms where cold air mass pushes into a warm air mass. The next one on the right, the top right, is an area where warm air is pushing into an area of cold air, creating a frontal boundary. What type of frontal boundary is that? Warm front. The bottom right shows an area where we have a cold air mass overtaking warm air mass and pushing into a colder air mass that was in front of the warm air mass, lifting the warm air mass off the ground. What type of front is this? Not convergent. It is an occluded front. An occluded front is an area where warm air is lifted aloft, up high, and the cold air kind of pushes its way right underneath. And then the last one right here is where we've got 2 air masses that are moving in opposite directions, so the frontal line does not move. What type of front occurs where 2 air masses move horizontally to one another and the front line does not move? A stationary front, all right? We want to now look at what type of weather is associated with each of these fronts. So in the upper left, going to the cold front, because I said that cold air likes to push in and kind of be a bully to warm air because it's more dense, it can actually push through very quickly. We had a cold front come through last night. How long did it rain last night? Not very much. Maybe 6 hours through the night. That's a pretty quick storm system. That cold air pushed in, it moved through very quickly. So with cold fronts, we get clouds and heavy precipitation, and it happens very quickly. A warm front. When a warm front pushes in, the warm front rides up on top of the cold front, leaving a line of clouds that is usually very long. And it extends out over top of that area of cold air for a very long distance. When we have a warm front move in, we usually get clouds and many days of precipitation. With an occluded front, we get clouds and precipitation. Sometimes it can happen for long periods of time. Usually it is not. Usually when we get an occluded front, we get clouds and precipitation that happen over a short period of time, and then that system slowly moves out. A stationary front, because the 2 air masses are not really moving in any way to cause the frontal location to move, we get clouds and many days of precipitation. So the frontal boundary between those 2 air masses may stay in the same location for days up to a week due to the movement of those air masses. So what weather do cyclones and anticyclones bring? Where air masses collide with one another, the boundary between the fronts sometimes becomes distorted. Other distortions can occur where air masses move around things like mountains, strong winds, or even the jet stream. When this happens, there is air that begins to swirl. The swirling air can cause a low pressure center to form. Cyclones. Cyclones are areas of low pressure. They are indicated on a weather map by the letter L. The swirling center of a low air pressure system is called a cyclone. As warm air in the center of a cyclone rises, it creates an immense area of low pressure. Cooler air from around the outside of that low pressure region comes in and blows into the central area. Winds spiral toward the center. In the northern hemisphere, the Coriolis effect causes a deflection of those winds. So in the northern hemisphere, cyclones spin counterclockwise when viewed from above. As air rises in the cyclone, the air cools and it forms clouds and precipitation. When we have cyclones that develop, it causes air pressure to decrease, and with that there is going to be cloud formation, wind, and precipitation. Anticyclones. An anticyclone is an area of high pressure. It is indicated on a weather map by the letter H. Winds spiral outward from a central area of high pressure and move towards areas of lower pressure. Due to Coriolis effect, those winds spin outward clockwise in our northern hemisphere. As air moves out from the central cool air, it moves downward from higher in the troposphere. As it sinks down from areas higher in the troposphere, it produces that higher pressure. So sinking air on top of you is going to produce high pressure above you. The cool air warms up, so its relative humidity drops. As relative humidity drops, we are not going to have any condensation that occurs. So the descending air in an anticyclone generally causes dry, clear weather. So looking at the picture that we have here we have visual representations of cyclones and anticyclones. The one on the left, notice that there is cloud formation at the top of the picture. It is rotating counterclockwise in its area of low pressure. Therefore, what type of atmospheric condition is this, Ms. Buck? It is a cyclone. The one on the right, we have an area of high pressure. The area of high pressure is spinning clockwise. It is going to be an anticyclone.